And we're back. All right, so now we're in the next episode and the next chapter, which is going to be Enums and Pattern Matching. Enums in Rust are actually what other languages call sum types. Okay? Really don't understand why languages always have to invent new names for things. Tell me about it. Tell me about it. I'm often thinking like, oh, well, this is a struct, which is like this in another language. Or this is an enum, but not that kind of enum. Or you enumerate, but not in the way that you're used to. Discriminated union in F#, which I've never coded in. If we're speaking of inventing new names for things, yeah. Yeah. People get excited when they're writing a language. And they're like, there's a reason they're writing a language in the first place. They're like, you got this wrong. I could do this better. And so they get creative. In this chapter, we'll look at enumerations, also referred to as enums. Enums allow you to define a type by enumerating its possible values. First, we'll define and use an enum to show how an enum can encode meaning along with data. To be fair, I don't think enum is a bad name, and some Rust enums can be layout compatible with C enums. I'll take your word for it. My C experience has been so long ago. Next, we'll explore a particularly useful enum called option, which expresses that a value can be either something or nothing. Option can be something or nothing. And we'll look at how pattern matching in the match expression makes it easy to run different code for different values of an enum. Okay, that makes sense. Finally, we'll cover the if-let construct, how the if-let construct is another convenient and concise idiom available to you to handle enums in your code. If everything in Rust, which is Haskell inspired, had the Haskell name, I feel like they'd be more confusing. Haskell inspired, I guess maybe? Maybe it is okay to differentiate. Enums are a feature in many languages, but their capabilities differ in each language. Rust enums are most similar to algebraic data types in functional languages such as F#, OCaml, and Haskell. Maybe it was OCaml I was thinking of instead of Lisp. It's always so hard to tell. Industrial strength. Programming language supporting functional, imperative, and object-oriented styles, all in one. Sounds like a good idea. If I recall correctly, first Rust compiler was in OCaml. Does Rust compile itself now? Seems like it would, right? It's always like the graduation step of a language. You can compile the language with itself. Yeah. Maybe to be fair, even Haskell has broken some of the naming from prior art. Sure. A reasonably intuitive name. I think so. We'll find out. All right, so on to enums. Defining an enum. So, situation we might want to express in code and see why enums are useful and more appropriate than structs in this case. Say we need to work with IP addresses. Currently, two major standards are used for IP addresses, version 4 and version 6. These are the only possibilities for an IP address that our program will come across. We can enumerate all possible values, which is where enumeration gets its name. Okay. Any IP address can be either a version 4 or IPv6 address, but not both at the same time. It's messing with me that they call it version 4 and not just IPv4, but that's just my brain. The property of IP addresses makes the enum data structure appropriate, but enum values because the enum values can only be one of the variants. Sure. Both IPv4 and v6 addresses are still fundamentally IP addresses, so they should be treated in the same type when the code is handled in situations that apply to IP addresses. Okay, but then so it's like pass in this type. It's an IP address. Okay, well, match on IPv4 and do this logic, match on v6 and do this logic. EverX, welcome back. Good morning. Good morning. What time is it where you're at, EverX? Because it's technically morning here. So you are right. It is definitely evening for me. 9:01. I would be so tired if that were the case. Enum values, we create instances of each of the two variants. Okay, so let's do this. So we are gonna do this. So why did I make that directory? I guess I could, you know what? I'm gonna do it. I'm gonna do it. And I'm gonna cargo init. Hey, CD chapter 6. I don't know why I tried to move it. Bad brain. Cargo init. Boom. What did it do? Yeah, you did. All right. Cool. We're gonna vim source main, and we'll just create our struct up here. And then I wonder if in enums, I don't think enums can have methods. All right, so we'll take these guys. Okay, so we've got 4 and 6. And we're going to create a function route. And I'm going to assume that it's going to take an IP address of a reference of IP address kind. Look at me guessing. IP kind, not a reference. They want to pass ownership. And I didn't do my colon. Okay. And we can route. So we'll route those. Wouldn't it just be 4, 6? Making stuff up. REST enums can be function pointers. Really? So I can, what you're saying is I can be like brain and I can create a function that takes self and call it test. What am I doing? It's getting late. This is what happens. Test self. I can just feel chat cringing right now. Hang on. I'll get there, guys. I'm just tired. We did it. Bumped. No. Different language. Different language. It's not the same. It's not the same, guys. And then, you know what? We'll just print here, because I don't want to deal with the derived debug. All right, so I don't think inline definitions work. Is that vim surround unsafe? I see. Vim surround usage? No, I'm actually not using vim surround. Vim surround had some odd behavior, so I just got rid of it. Yeah, I'm not sure what you mean by inline either. Yeah. Okay, I'm just going to do this real quick. I'm just going to say 6.test. And then I'm going to, this should be fine. Oop. Chapter 6. And then cargo run. Oh. Did we get, so we did get here. So yeah, that works. Weird. Okay, cool. I like that. Yeah, args that are arg. That's a horribly ambiguous word. I meant in place. Gotcha. Yep, I hear ya. But this worked. This certainly worked. So, interesting. I'm not going to use that. And then it's going to complain. Does that won't compile? No, it compiles. Just complains. Warnings. I'm okay with warnings. Okay. So, we've got the IP address kind, a struct of IP address, which has kind and address. Okay. Yeah. I will say struct for IP address, and it'll have type of IP address kind, and what do we call it? Address. U32 string. String because of all of the periods and colons and so on and so forth. And now comes a form. Type is a keyword if I recall correctly. Type is a keyword. Probably. Yes it is. If you really want to use it as an identifier, you need to escape it using r:type. A colon pound type. In which case, anything in there. Yeah, okay. I haven't learned about R, what that does yet. Oh, they're kind. They're calling it kind. I see why you said that. I'm smart. All right. So then we're going to create home and loop back. And I'm just going to copy these because that just seems like more typing than I want to do at this exact moment. Okay. Home, loop back, and then we'll route home. Route loop back. Because we need to take IP address. From that, we interpret the kind. Is it saying these are never used? That's fine. I'm going to get rid of this implementation. Okay. Yep, I know what we're doing there. We can represent the same concept in a more concise way using just an enum, rather than an enum inside of a struct. Before string okay, I'm down. So we can have our types, and then we can just specify them as what looks like associative functions. Variants will have associated string values. So they're not functions because they are literally strings. Makes sense. We attach data to each variant of the enum directly, so there's no need for an extra struct. Okay, so let's do that. Boop. Let home equal IP address v4 127.0.0.1. I don't have a 10 key on this keyboard. It's a tragedy. Work. String from okay. Loop back. And then ta-da. All right, all that makes sense. There's another advantage to using enum rather than struct. Each variant can have different types and amounts of associated data. Cool. Version for IP addresses will always have 4 numeric components that will have values 0 to 255. If we want to store a v4 address as 4u8 values but still express v6 as a string, we can do that. We wouldn't be able to do that with a struct. Cool. And then I could have an implementation on IP address and say like get v4 address, and it could parse that into a string. Potentially, I don't know. We've shown several different ways to define data structures to store version 4 and version 6 IP addresses. As it turns out, wanting to store IP addresses and encode which kind they are is so common that the standard library has a definition we can use. Let's look at how the standard library defines IP addresses. 2 structs and an enum that take those structs as types. Okay. Code illustrates that you can put any kind of data inside of an enum variant, strings, numeric types, or structs, for example. Probably also tuple. What are they called? Struct tuples? I forget what they're called. You can even include another enum. Enum's turtles all the way down. Also, standard library types tuple structs. Yeah, and functions, as I mentioned earlier. Yeah, for sure. So Rust tuple struct. Tuple structs. Boom. So you create a struct of a color, and it's really just a tuple. And for each, because tuple are fixed width, you can define the type for each inside of there, and then you create the tuple, and then you can type the tuple coming in to a function somewhere. Anyway, if you were to pass this into a function, you could pass it as reference of color, and then you wouldn't have to worry about it being any tuple. It's a typed tuple. Standard library uses. Okay, so wait. Even the standard library contains a definition of IP address. We can still create and use our own definition without conflict because we haven't brought the standard library's definition into our scope. Okay. But if we did, it would probably be a problem. Let's look at another example of enum in 6.2. This one has a wide variety of types embedded in its variants. So, quit, which takes nothing. Okay, yeah, right. This is an enum, not a struct. Quit, move with an expression, x and y, as 32 and 32. Are these, is that an enum? I'm not sure. Write, string, change color. Are these functions? I don't know. I'm going to have to figure it out. Move contains a struct. Move is a struct. without a struct keyword? Or, oh, no, I don't know. Just how you have the structs and tuple structs, you can have a struct-like variant and tuple-like variants. Okay. A message enum whose variants each store different amounts of types of values. The move enum variant contains a struct as data. Move contains a struct. Okay. Quit has no data associated with it. Move includes an anonymous struct. Anonymous struct. That's what I was looking for. That makes sense enough to me. Write includes a single string, and change color includes 3 I32 values. As a anonymous tuple struct, perhaps. Defining an enum with variants such as one's listing in listing 6.2 is similar to defining different kinds of struct definitions, except the enum doesn't use the struct keyword, and all the variants are grouped together under the message type. The following structs could hold the same data that the preceding enum variants hold. Right, so we have a struct for quit message, a struct for move message, which is no longer anonymous. Yeah, but then you're like message everywhere, like group them. At the moment, variants aren't types themselves, if I recall correctly. There's an RFC for it. Are these, when you say variants, is it like what's a variant in here? Did I miss a variety? Like a variant? Variant. I'll have to look that up perhaps. Quit is a variant of the message enum. Move, quit, write are variants. So basically, the fields of an enum, they're not fields, they're variants. Defining an enum with variants, there it is. There's the word. Such as the ones, understood. All right. Quit message, move message, write message, change color message, tuple struct. Right, so it was a tuple struct. And this is a tuple struct as well. Just takes one in as its variant. Okay, but we use different structs which have their own type. We could easily define a function to take any of these kinds of messages. Couldn't easily write a function as we could with the message enum. Makes sense. A tuple struct with one type is often called a new type. Okay, since it's just a new type that wraps the other one. Yeah, I think I read something about that in past chapters. There is one more similarity between enums and structs, just as we're able to define methods. Hey, I already figured that out. I figured it out for myself. You can implement a message call defined under message enum. The body of the method would use self to get to the value that we called the method on. Getting tired here, guys. In this example, we've created a variant m that has the value of message, write, string from hello, and that is what self will be in the body of the call method when m.call runs. M, right? M is message is here, call is here, so m, this is self in call. Easy to understand. Yeah, totally easy to understand. Let's look at another enum in the standard library that is very common and useful. I'm gonna make a note here. We're just gonna touch show notes. We're gonna say learning Rust, chapter 6. Chapter 6. Enums.md. We're gonna vim that. We're gonna be like chapter 6 notes. We need to mess with struct struct variance. No. Enum variance. We need to create methods. Are they called methods? Methods on enums and play with functionality. Okay. The option enum and its advantage over null values. In previous section, we looked at how IP address enum let us use Rust's type system to encode more information than just the data into our program. This section explores a case study of option, which is another enum defined by the standard library. The option type is used in many places because it encodes the very common scenario in which the value could be something or it could be nothing. So it's like a nullable type. Expressing, I'm making that up, I don't know. Expressing this concept in terms of the type system means the compiler can check whether you've handled all the cases you should be handling. This functionality can prevent bugs that are extremely common in other programming languages. Programming language design is often thought of in terms of which features you include, but the features you exclude are important too, a la Go and Rust. Rust doesn't have the null feature that many other languages have. Null is a value that means there are no value there. There is no value there. Blech. In languages with null, variables can always be one of these two states, null or not null. Better than the nullable type. Let's find out why. In his 2019 presentation, Null References, the billion-dollar mistake, Tony Hoare, the inventor of null, has this to say. I call it my billion-dollar mistake. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in that null reference, simply because it was so easy to implement. This sounds like PHP all over again. This has led to numerous errors, vulnerabilities, and system crashes, which have probably caused billions of dollars of pain and damage in the last 40 years. Probably. Who knows? Probably crashed something on the moon at some point, right? Because of a null. No, doubt it. The problem with null values is that if you try to use a null value as a not null value, you get an error of some kind. Because this null or not null property is pervasive, it's extremely easy to make this kind of error. Problem with null is mostly because deref of nulls is undefined. Yeah, especially when you're dealing with references. That would be a big, big problem. If it were defined in some other reasonable way, it would be okay as well. Okay, the concept that null is trying to express is still a useful one. A null value that is currently invalid or absent for some reason. Sure. The problem isn't really with the concept, but the particular implementation, as Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This is the option generic type, and it is defined by the standard library as follows. Some type or none. Okay. For example, you could default to have every null deref to itself evaluate to null. Yeah. The awesome thing about the option type, more than that nullable type in your opinion, is that it forces you to unpack the sum to get the value and realize that none is also an option and it's safe. Truth is that you making it an explicit concept in a language, gives you the ability to make that decision yourself. Yeah, that definitely would. Just still on this other one, option as it is safe. Okay. The option type or generic type enum is so useful that it's even included in the prelude, which is the standard library code that is included without you having to include anything. You don't need to bring it into scope explicitly. In addition, so are its variants. You can use some and none directly without the option prefix. Interesting. The option generic enum is still just a regular enum. Some type and none are still variants of option type. Okay. It was just like sort of detached from it. The T syntax is a feature of Rust we haven't talked about. It's a generic type parameter. We'll cover generics in more detail in chapter 10. For now, all you need to know is generic type means some variant of the option enum can hold one piece of data of any type. Here are some examples of the option values to hold a number of types. So you've got an integer, a string, and an I32 to none. Option I32 equals none. Oh, of type, yeah, okay. If we use none rather than some, we need to tell Rust of what type option T we have. Because the compiler can't infer the type that the sum variant will hold by looking only at the none value. When we have some value, we know that a value is present and the value is held within the sum. When we have a none value, in some sense, it means the same thing as null. We don't have a valid value. So why is having option T better than having null? Option T, and in short, because option T and T, where T can be any type, thank you, generics, are different types. The compiler won't let us use option T value as if it were definitely a valid value. For example, this code won't compile because it's trying to add an I8 to option I8. Oh man. Okay, hang on. X, which is an integer, an 8-bit byte, integer, let Y option I8 equal sum 5. X plus Y. Trait bound I8 standard ops add standard options I8 is not satisfied. No implementation for I8 plus. Okay. Okay. Understood, I think. Yeah. Intense. I agree. In effect, this error means that Rust doesn't understand how to add I8 to an option I8 because they're different types. When we have a value of a type like I8 in Rust, the compiler will ensure that we always have a valid value. We can proceed confidently without having to check for null before using the value. Only when you use an option of I8 do we have to worry about possibly not having the value, and the compiler will make sure we handle that case with a match before using the value. Show me the matches. In other words, you have to convert option T to T before you can perform T operations with it. Yes, understood. Generally, this helps catch one of the most common mistakes with null, assuming that something isn't null when it actually is. Yes, very true. Not having to worry about incorrectly assuming a not null value helps you be more confident in your code. Ooh, I understand. You can safely assume that the type isn't null. Yeah. Right. Options can be null, and you have to check those. Because you're not confident until you have a type that is not in an option. Okay, So how do you get t value out of some variant when you have a variant or value of type option t? Option t enum has a large number of methods that are useful in a variety of situations. You can check out the documentation, which I will. Becoming familiar with methods option generic type will be extremely useful in your journey with Rust. In order to use a option t value, you want to have code that will handle each variant. You want some code that will run only when you have some type value, and this code is allowed to use the inner t. You want some other code that'll run if you have none, and this code doesn't have t available. The match expression is the control flow construct that does just this with enums. Okay. That was like the most long-winded way to explain generics and matching generics to get to the inner type. I need to take a breather after that one. I guess if it's your first time ever using generics, then that's probably a good explanation. Yeah. Who do we still have here? Oh, plenty of people. Okay, so where are we at in this chapter? Did I dig a hole I can't get out of? How long is this? Oh, it's fine. It's fine. We can do this. Oh, it's totally fine. Match control flow operator. Well, no, I've already used match a little bit. Think of match as an expression as being like coin sorting machine, coin slide down a track with various sized holes along it. Each coin falls through the first hole it encounters that it fits into. So it's like bigger, bigger, bigger. Last catch. Got it. There's a trade-off, though, with option, namely that it necessarily forces some verbosity, some of which you can get back with macros. People tend to underestimate verbosity. It often influences program design unconsciously. Yeah, I mean, I guess the question is underestimate in which direction. Like, verbosity can be very good. It can make very readable code, very reasonable code, so verbosity can be good. The other side of that is verbosity can lead to just a huge pull request and can obfuscate what you're actually trying to do and doesn't provide itself as an elegant solution. Yeah, you would definitely have null checks, for sure, 100%. All right, so fits into the same way. Values go through each pattern in match. Pattern that fits the value falls into the associated code block. I mean, it's kind of like a switch, like a case statement. If you're comparing to other programming or procedural languages, yes. And compared to that, it's better. Yeah, I agree. Okay, so here we go. Okay, so we're going to move main rs to defining enum. Define enum.rs, and then we're gonna cp that to main, and we'll go back into main. Nobody ignore that I moved and copied in that way, like a silly person. Okay. Ta-da! Do I have something in my clipboard? Sure do. This should be, you should both be outside of here. Well, value in cents takes a coin and matches, so we can have that in main. Actually, no, I don't know what I was thinking. Don't know what I was thinking. And then we'll just value in cents this. Okay. You don't want to fix my... Oh, wait. What am I doing wrong? Okay, so we need a coin. Let coin. Let coin equal to coin. And then... Oh, it's an enum. Enum. We got an enum here. How do I... Let's find out. One thing that may be interesting to think about is this necessarily forces null checks on the API consumer, whereas you could design functions that all options as arguments and do null checks on the function inputs, therefore yielding a clean API. Of course, the same thing can be done in Rust, just that I have rarely seen it. I don't think I have enough context for that comment, to be quite honest. You'd have to wrap them in option or have two variants. Yeah. Okay, so let's break it down. Match in the value in cents. Well, this is easy, right? So you got a penny, nickel, dime, quarter. You pass that in. And then coin penny is 1, 5, 10, 25. And then you just return whichever one it is. So I forget how to make an instance of a coin in an enum. Rust enum instance, we'll say. Instance of a variant by typing its name with like colons. I forget, like this. Enum event key press. Yeah. Okay. Cool. Didn't absorb that at all. Same as you match it. Got it. Okay, so we would say let coin equal to a nickel. And then we'd pass in coin. Wrong. So this takes a char, page unload. What am I missing? Oh God, really? Just tab complete everything. Always tab complete everything. All right, coin goes in. We say do this thing, and we get the value in cents, and we say we print line. See, you know how helpful it would be having just like someone that basically, I'll get this one day. One day I'll understand that print line is a formatter, and it just won't be a problem anymore. Yeah, just having someone sit over your shoulder and they're like, typo. It would just, like, the amount of money probably saved in typos would be not worth how much that person probably gets paid. All right. Cargo run. 5. Nailed it. Guys, we did it. I think that's this whole chapter, right? That's all we needed. I don't need to... This is one I don't need to break down. Right? I fully understand what's happening here. Yep. Pattern matches the value. Code associated is executed. And then we can also have an expression, and it can do all sorts of code, and then return the value. Curly brackets typically aren't used if the match arm is short. If you want to roll multiple lines, you can use curly braces. Matching on variants with data is interesting. Okay, well, let's get to that section. Another useful feature of arms is that they can bind into parts of the value that match the pattern. This is how we can extract values out of enum variants. As an example, let's change one of our enum variants to hold data inside of it. From 1999 through 2008, the United States minted quarters with different designs for each of the 50 states on one side. That's true, they did do that. No other coins got state designs, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include US state value. We've done here. So here's our states: Alabama, Alaska, and so on. The quarter takes a state. Inside of our match, we can say, if you match a coin quarter with the state, I forget, okay, match to this, the state quarter is from here, we return 25. Yeah. That makes sense. Matching with an option T. Here we go. In this section, we wanted to get the inner T value of the sum case where we're using option T. We can also handle option T using match, as we did with coin enum. Instead of comparing coins, we'll compare the variance of option T. But the way that we match expression works remains the same. So let's say we want to write our function that it takes an option of integer 32, and if there's values inside, adds 1 to that value, like a map, perhaps. If there isn't a value inside, the function should return the none value and not attempt to perform any operations. Function is very easy to write thanks to match, and we'll look at the listing in 6.5. Okay, so if you get none comes back. I'm not sure what's going to happen here, so let's just take this. Option 32, yeah. So basically, I'm going to save and quit this, and I'm gonna copy main rs as coin.rs, and then we'll go back into main, and we'll get rid of some stuff here. Okay. Print line. This is it, guys. I'm gonna get it this time. Oh, I did it. We'll do that, and then we'll print 5, 6, none. What did I do wrong? Doesn't implement formatted with the default formatter. Can I do like U? Well, let's do that. Okay. All right. Let's run this bad boy. Some 5, some 6, none. Okay. Understood. Let's examine the first execution of +1. In more detail, we call +5, or +1, 5. The variable x in the body of +1 will have the value sum 5. Then compare that against each match arm. Good. Does sum 5 match sum I? Why, yes, it does. We have the same variant. The I binds to the value contained in sum. So I takes the value 5. The code in the match arm is then executed, so we add 1 to the value of I, and we create a new sum value with our total 6 inside. Right? Yeah. 5 becomes... Okay. Yes. Yeah. Sorry. Sum 5. 5 becomes 6. None remains none. Now consider where x is none, we enter none. In the match, there is no value to add, so the program stops and returns none value on the right side of the arrow, fat arrow. Because of the first arm of the method, no other arms are compared. And because none is none, we can't pass it in to anything that expects the integer out. We're gonna get a compilation error at that point, which we could prove out here. Function example compilation error. Compilation error takes a what are we dealing with here? I32, and it's just going to print line number okay, and then we're gonna say example compilation error 6 should be fine. Oh, sorry. How do we get... So the only way we could get... Okay, here we go. That's what it is, right? So because it's an option, because of sum, the only time we could pass it is if we were in here. Well, what if we just returned this guy, and from here, right, because we're returning an option, if I were to do this, we would get, that's weird, we would get an error on none, because the types don't match. So none would literally have to return like 0. And then we wouldn't get compilation errors. Got it. Okay. Matches are exhaustive. There's one other aspect of match that we need to discuss. Consider this version of +1 function that has a bug and won't compile. Okay, so let's see if I can figure out the bug. Option I32 comes in, option I32 goes out. Match sum of I. Oh, because, yeah, it's like none not covered. It's like you have to figure out your stuff. Okay. When Rust prevents us from forgetting explicitly to handle none case, it protects us from assuming that we have a value when we might have null. Check it. You must. The underscore placeholder, Rust also has a pattern we can use when we don't want to list all possible values. For example, unsigned integer 8 can have valid values of 0 through 255. Sure can. If only care about 1, 3, 5, 7, we don't want to have to list out 0, 2, 4, 6, 8, 9, all the way up to 255. We can use underscore to return none, or to do nothing. So let's just make an example out of that. explicit none.m.rs. Okay, so I think this all goes away now. And then I just paste this. And I don't want to print these. Instead, I want to return I. How did we match that before? E explicit. Oh, we had to sum, which we're not doing. Sum I. So basically, can I have my reference in here? Or would I have to do like literally return 1 plus 1? And what am I doing? Why did I do return? I don't know. Oh man, now I'm really killing it. Well, in that case, you just use some U8 value because that is the value you matched. Right. Why is this complaining now? And nothing has changed here. Sum 5. Option none sum. Match arms have incompatible types. Expected integer found, nothing passed in. Is this related? I think it's related to this. Found to be of type integer. U8. Okay. Right. I'm just going to leave it for now. I understand the concept. By putting it after our other arms, the underscore will match all possible cases that aren't specified before it. So just out of an abundance of curiosity. 0 U8. Expected nothing. Oh. Okay, so what if I created a function called map it? And then I paste this inside of here, and then it has a return type of U8. And then I return 1 plus 1. Match sum U8, and it takes in a U8. And it's called number. And then we say map it some U8 value, but we pass it as a reference. No, we pass ownership. And then we get back our let new val equal to map it. You could have done it before, but all match arms need to be the same type. Got it. Okay, I will try that. We're just going to change this. This is going to be 1, right? Expected U8. Found nothing. What am I? Let some U8 value equal 1. 1 U8. Okay. But now it's complaining. Found. Oh, I think it's. Let's just do this. Let's just complete the operation here. Return 0. Return 7. Say return. Yeah, I've got some curiosities that are probably going to be answered by the book. In Mapit, you got to change the match variable name to number. Getting tired. Really tired because I'm missing some stuff here. 6, 7, and this will just be 0. Took way too long. So let's be. I've got some ideas. We can play with this some more. Print line. New val. Okay. 1 becomes 2, and then if I did it like 2, I'd get 0. What I'm curious about is like, can I have whatever value is represented in this underscore? Let's find out. However, the match expression can be a bit wordy in a situation. I figured, okay. Like, there we go. Yeah, okay. X plus, or we're going to square it. No, we're not, because powers are weird in here, and I don't fully remember how to do them at this moment. So we're just going to multiply it by 2. So 2 should be 4. Quick maths. Okay. Got it. Okay. If let syntax lets you combine if and let into a less verbose way to handle these values. Okay. If let sum 3, place this into here. Yeah, it's just a variable name with a special meaning that you don't care about the value. Yeah, same concept in Go. Yep, you can just ignore it and the compiler will be like, all right, if you say so. Okay, rest optimizes differently. Yeah, probably doesn't have to allocate memory on the stack and the heap. So it doesn't have to have a pointer or a heap reference for it. Instead, you could write a shorter way. So we've got this let of this value. And then we just sum 3. What about if we have multiples? Is if let only operate on 1? I think I need to read this. To satisfy the match expression, we have to add an underscore after it's preceding just one variant, which is a lot of boilerplate code. So this assumes that underscore nothing. But I feel like that wouldn't work very well. So this is copy main to mapping So what if do I have to define it? We've got count. Let's count increments. Cannot find some U8 value in this scope, but I'm defining it. I guess what it needs to return 5. Just playing with ideas. Other way around? Which way? Which way? I mean, they gave it to me. Let's see if I can work my way through this. Sum 3. This is 0. So I have to define it first. Look at the if let example. I think I am. The if let takes a pattern and an expression separated by an equal sign. It works the same way as match, where the expression is given to the match and the pattern in the first arm. Oh, so it is let some U8 value equal to sum 3. Maybe. Yeah. Okay. So it's really only saving this. I'm preferring the match syntax myself. I'm sure I would find reasons to use if let. Yes, only for the case where you care about one value. Right. Right. And then, so what if I just return 5? What happens? Your function gets some enum, and you care about if it's a certain variant, right? Like you have 100 shapes and you care about a circle, right? Okay. I'm gonna have to come back and play with these more. I can tell from here. We're gonna do something with sum 3. You'll get an error because you have a semicolon after the 5. Yeah, understood. I wonder, will it? It seems pretty happy. Can I be like, let thing equal if let? Like, how do, Yeah, yeah. Oh, huh. Yeah, I agree. And now I get an error because expected nothing and found an integer. So it's like, let thing equal and now what? This? I don't know. That returns had to have no semicolon. I thought so too. You do let sum x equals sum. Equals sum? If let sum x equals sum ... I'm confused by that. Oh. Oh. I think I understand. No, I don't know. Isn't that what I'm doing? Are you saying literal x here? Unused variable x. Oh. Caught myself. I caught it. I did it. Huh. If let sum x equal this, return 5. Oh, no. X is only valid in scope. Yeah, but like I want to... Hang on. Explicit none, mapping. Like here. I was like, return this. And then it was like, okay, out it goes. You can do this. Okay. I'm ready to do this. I just feel like a return here is what I want. And I want to like let thing equal that. But it's all angry about that. If, yeah, let x equal if let x value 5 else. Do I have to else? Is that what it is? So if I say let x equal to if let sum x else 1. And then I should be able to get rid of those. But I can't. I mean, I think we did the same thing. Only difference is I can get rid of these. But then it's definitely not happy. I think so too. This just feels weird. What's the error? There's a few. So this one is expected dot, comma, semicolon, or operator found print line, unexpected token, which is solved by these. I think. Maybe not. Maybe my else is messed up. Let x. Do I have to say after the find? Oh my lord. Okay. Got it. Oh my god. 5. One. Okay. Now instead of 5, you can do x plus 5. Right. Yeah, you can do. Oh, okay. I see. X plus, and then we can say replace with x. And then we'll just say x plus 1. Oh, else. Yeah, this is when you don't care. Well, can we? That was hopeful. What about this? Else is none in that case. Okay. Well, okay. I get it. Yeah, because, okay. Fully following. Okay. So, to reiterate, we instantiate a variable called sum u8 value. We give it a value of sum 1. Then we instantiate a variable x, and it's going to be equal to a value if it's going to be equal to a uint if let sum of any any none value, then for U8 value cast into X, we're going to X plus 5, that value. Oh, I'm hitting my trackpad with my palm is what's happening. Else 1. Sum Y and Y plus 5. Okay, whoa, okay. There's a lot in chat. If you keep the sum X, else is the none case. This is a weird example, I agree. Maybe the inner X call Y. Yeah. So it's like, but it highlights that you can call them whatever you want. I understand. I'm going to rename this. I'm going to copy main to let if let example. Okay, where are we at through the book? Oh, thank goodness. Okay. All right, so that all makes sense. Took a while, but it makes sense. So we can include an else with the if let. The block of code goes with the else is the same block of code that would go with the underscore case in the match expression that is equivalent to the if let else. Recall the coin enum definition in listing 6.4, where the quarter variant also held a US state. If we wanted, we could count all non-quarter coins we see while also announcing the state quarters. We could use that with match expression like this. None would factor into this as well. If you wanted none to be something else, then you would have to use the match. If you just wanted the 2, quarter or anything else, including no coin. But that's weird, because then it's like, coin doesn't have none. Oh, right. Right you are. Okay, so let mutable count equal 0. If let coin quarter state coin. If let quarter state gets passed in equal to coin. Print state quarter came from this state, otherwise increase. In summary, at 2 a.m. 2:15, now we've covered how to use enums to create custom types that can be one of a set of enumerated values. We've shown how the standard library's option T helps you use the type system to prevent errors. When enum values have data inside of them, you can use match or if let to extract those values. Probably time to sleep. Definitely time to sleep. You can use match or if let to extract those values depending on how many cases you need to handle. The Rust program can now express concepts in your domain using structs and enums, really like enums, creating custom types to use in your API to ensure safety. The compiler will make certain that your functions get only values of the type each function expects. In order to provide a well-organized API to your users that is straightforward to use and only exposes exactly what your users will need. Let's now turn to Rust modules next time on the Rust book here on Terminal Bash. 8-hour difference means you're somewhere in the West US. You are right. Intuitive deduction, good reasoning. All right, so next time we're going to talk about managing growing projects with packages, crates, and modules. And we're going to start to get into a little more architecture. So looking forward to it, but for now, I say good night, and thanks for tuning into the stream, and see you next time.